Hello and welcome to Talk Julia. My name is David Amos.
And my name's Randy Davila.
Let's start by talking about file I/O in Julia. There's an article I found by Ifihanagbara Olusheye, and I apologize if I butchered your name, called What is File I/O in Julia? And it's a short overview of how to create, open, read, write to, and close files in Julia. And I thought we'd just kind of go through and mention a couple of the functions that you would use a lot when working with files in Julia. So first of all, this is not specific to any kind of file format, right? So this isn't like, if you want to work with CSV files, there's a package, the CSV package, that's more specific. You could sort of recreate some of that stuff from scratch using some of the functions we'll talk about here. But, if you're working with a very specific file type, there's probably a package that you would use to do that. But in general, if you're just reading from a text file or from a binary file or something, you would use these kinds of functions.
Well, you should be able to create CSV files, and any file with, if you know the extension, you should be able to create that using, for example, this touch function.
Right. Yeah, you can create anything using touch.
Yeah.
For example, here she's creating a demo.txt file. If you want to open a file, there's the open function. And all of these functions are in like the Julia base package. So you don't have to import anything to use any of these. They're just there for you. You just type open and it just works, or touch and it just works. If you want to open a file, you use this open function and you pass to it at least two things. There's the path to the file as a string, in this case, demo.txt. And since there isn't a full path specified here, that is using whatever the current working directory is, which you can find by using the pwd function if you're not sure what the current working directory is. And then you also pass a mode. So this R is specifying that you want to open the file in read mode. You could pass something like W for writing. You could pass A for append. For reading a file, there is the read function. And for writing to a file, there is the write function. And if you need to close a file, then you use the close function. So when you open a file, what gets returned is a file descriptor. And you can assign that to a variable, and you can pass that around to these different functions if need be. And that's what you would then pass to the close function to close that connection to that descriptor.
So, David, I have a question real fast.
Yeah.
So in Python, there's this like with open do like write to the file, like, and it closes automatically the file after you open it. So why is it important to always close the file? Like, why is this emphasized?
Well, when your program stops running, your operating system, in theory, will clean up all the resources when it's done. So if you don't explicitly close a file, then in theory, it should get closed automatically at some point after you stop running your program. But that at some point is completely unknown, and it may not ever actually happen. It just depends on a lot of things. So It's just best practice to just clean up all the resources that you use. So when you open a file, you're using resources on the computer. When your program is done, it should, for the most part, leave the computer back in its original state, unless it's something that was specific, if you were like creating files or something, and those would be now on the file system. But yeah, you just want to clean up after yourself, basically.
Right.
So it's just a good practice, because you don't know what's going to happen after that. If it doesn't get released, then you're not letting other programs potentially or other operating system functions.
I see what you're saying. Yeah. So maybe like the Julia version of like that Python thing I was talking about would be like to wrap this in like a do block or something. It's like some type of code block where you open it and then you close it and then end out that block of code.
Yeah, that's exactly right. And in the Julia docs, there is a section called IO and network. And if you go to the open function, so let me just search for open, and there's an example of doing exactly that.
Okay.
So what this does is, so the syntax here is you type open parentheses, you give it the path to the file you'd like to open in the first argument. The second argument is the mode, so read, write, or whatever. And then you close the parentheses, and then followed by the keyword do. And then after that is the name that you want to give the file descriptor. So in this example, they've opened myfile.txt in writing mode, and then do IO. So there's a variable called IO now that is a reference to that file descriptor. and that opens a do block. And inside of that, you can do all sorts of things with the file. In this example, they're writing the string hello world to the file using the write function. So they do write open parentheses. First argument is IO. Second argument is the string hello world. And then on the last line is the end to that do block. And what happens is this will open the file, assign that file descriptor that gets opened to a variable called IO, write the string hello world to the file, and then when it hits the end and comes out of the do block, it will close the file descriptor automatically.
Okay, so that's exactly like the Python syntax that I'm familiar with.
It's very similar.
It's just like with Python, it's like with open as file,
right?
Do stuff, right? So
yeah. So this is a good pattern to know. However, there is a couple of things to be aware of here, and that is that you don't have to open a file before you write to it. So if you want to do multiple things with a file, opening it and then using this do block is probably a good pattern to follow. And you can do a bunch of stuff inside of the do block. And then when the do block ends, it'll close the file descriptor. But if all you want to do is just write some text to a file, you don't actually have to do it like this. And I can show you what I mean. So let me start my Julia REPL. First of all, I'm in a directory that I've got on my computer for this episode, and there shouldn't be anything inside of it right now. No, there's not. So I'm going to open the Julia REPL, and I am going to type write, and I'm going to call this hello.txt. So string hello.txt to the first argument. Actually, before I do that, let me show you the pwd command. I know you know this, Randy, but to some of our listeners that may not be aware of this, I want to make sure that my current working directory is the directory that I think it is. It should be this talkjulia/episode/12/examples. And if I type pwd with no arguments, just call that function with no arguments, I get a string that is the absolute path to that directory that I'm in. So that confirms that I'm in the right directory. And then if I want to create a file called hello.txt with the string hello world in it, I type write. The first argument is the path to the file I want to create. And I'm just going to do hello.txt with no additional path there. So it's just in my current working directory, and the string hello world. And when I write that, first of all, you'll see it returns the integer 12, which is basically the number of characters that got written, or number of bytes, I think, in more generally the number of bytes. But if we count the length of the string hello world, the way I have it written, it's 12. So, but now that I've written that, it's created that file hello.txt for me, and it's also closed the file description, everything as well. So that's just a quick way to write, and I can confirm that. I can type readdir, readdir, and call that function with no arguments, and it'll give me a vector with everything that's inside of my current working directory, and I can see that there is now the hello.txt. And the same thing goes for reading from a file. So I don't need to open the file explicitly before I read from it. So if I want to read what's inside of hello.txt, I type read and then open parentheses. I give it the path to the file I want to open, hello.txt, and then the type that I want it to be read into. So in this case, I want it to read into a string type. And so I'll pass the string with a capital S as the second argument to read. And when I hit enter, I get the string hello world that was inside of my file. Now it's kind of interesting. You can, if you don't give a type to the read function, so if I call read hello.txt with no second argument, so I'm not telling it what kind of type to read into, it's going to default to bytes. And so I get a 12 element vector here of unsigned 8-bit integers, because these are all ASCII characters. And I can see it's giving me the byte values in hexadecimal here. So I get a 12 element vector because they're 12 characters, and I get the hexadecimal representation of each character. And you can do things like, if I wanted to read just the first character from the file hello.txt, I would do read string hello.txt, and then the second argument I would pass the char type or car type. And when I do that, I get the capital letter H, and it tells me that it's an ASCII character. It also tells me what the Unicode code point is for it. And there's a category. In this case, it's an uppercase letter. So it gives me some additional information about what that character is.
So is it returning just the letter, that character H? Do @show read that thing? I'm just curious. Nice.
Yeah, read hello text car equals H. So it just gives me that first letter. So yeah, so that's just some real quick basics on reading and writing with files in Julia. And there's a couple of really cool things just to keep in mind too, working with the file system. So we mentioned the pwd function to get the current working directory. And then we talked about readdir to get a vector of all the things that are inside of a directory. We saw the touch function where we can use to touch, to create a file. So if I create a file, let's just call it new file.txt. Then when I do readdir, now I see that I have the hello.txt and the new file.txt in it. If you want to get information about a file, you can use the stat function. If you've used a Unix operating system before or worked a lot in Unix type terminals, you're probably familiar with stat and what it does, but it'll give you some information about it. So if I do new file.txt inside of the stat function, then it tells me, for example, I've got, the size of the file. In this case, there's nothing in it, so it's 0 bytes. It gives me like the device ID, the mode. So this is like the permissions and things like that, the user ID of the owner, all sorts of stuff. And then you also get the time of like when it was created and all that kind of stuff. So there's also stuff for creating directories and CDing into directories, all that kind of stuff. So there is a makedir function. And let's say I want to make a directory called test, I guess. Then if I do readdir, now I see I have this third element in the vector I get from readdir called test.
There it is.
And I can actually check, is that a directory test? And it's true. So I use the isdir function to see if something is a directory. And that will return false on something like hello.txt. So if I call isdir with the hello.txt as a string argument, it says false because that's not a directory. And you also have an isFile function. So isFile string test returns false because test is not a file, it's a directory, but isFile hello.txt returns true.
These functions also work with like Boolean checks. So for example, if you did in quotes hello.txt in quotes in readdir close parentheses, it would return true.
Oh, sure. Yeah.
Yeah. Like they, because these are returning like Julia objects, right?
Yeah, exactly. Readdir returns a vector. So anything that you can do with a vector will work there. So you can use like the in. So if I want to cd into the test folder, I use the cd function test, and it doesn't return anything. So I don't see any output. But if I now do my pwd, call the pwd function, then it shows that my current working directory is now inside of that test folder, inside of the examples folder that I was in before. And actually, I haven't tried this before. What happens if I do cd and the string ... It does take me back one, yeah. So if I want to move a file, so let's say I want to move hello.txt into the test folder, I use the mv function, which is the same as like in a Unix file system, right? You use the mv command. So I would move, and actually let me do the help on this. So I can use mv, for example, to rename a file, but I can also move it into another directory. So the first argument that you pass to mv is the file that you want to move or rename. And then the second argument is the path that you want to move that file to. So if I do mv hello.txt, and then I'm going to do test hello.txt, then if I do readdir, I no longer have hello.txt inside of my current working directory. But if I cd into the test directory, and then I do readdir, there's the hello.txt inside of that. So there's a lot of these functions that are there for you to work with. Oh, I guess one important one we should mention last of all is if I want to delete a file, it's the rm function. So if I do rm hello.txt, now when I do readdir, I get an empty vector because there's now nothing inside of the test folder because I deleted that file. So there's a lot of these there for you, and it's kind of nice. I like it because, well, I use a Mac, and prior to using a Mac, I primarily used Linux. So these names are just what I'm used to when it comes to working with a file system. But the other nice thing is then it gives you a sort of platform agnostic way of working with the file system. So if you're working with someone that's working on a Windows computer, then all of these functions are going to work exactly the same way.
And as an instructor, I really appreciate that. In the past, I've had to have students download like VirtualBox and install like a virtual machine with like Ubuntu or something to work with these like file systems, right?
Yeah.
And getting used to the terminal. Julia allows me in the future to do this, like regardless of what computer they're on, right? Just like you were saying.
Yep, it's
And
just one command. It works on whatever platform you're.
And yes, there are like subtle differences, but like the basic functions and general idea of directory structures is maintained.
So Randy, what do you got for us?
Well, I think I'll start with a package that I came across recently. And this package I found because I have started and I'm getting close to finishing that automated conjecturing program that I said that I would get on this summer in Julia a few episodes back. So I've started working on that, and a part of its interface is to have a terminal output for the user to look at when they're waiting on conjectures to be made. In Python, I used a package called FIGlet, and it turns out FIGlet is also in Julia with FIGlet.jl. So on the screen in front of me, I have the FIGlet.jl homepage, and if I go to usage, you'll see some rather like meek documentation, but it's a very simple wrapper behind the Python FIGlet package. So if you just go to the examples, you'll see various output for, how would you describe this? Is it just like formatting fonts for the output, David? Yeah, ASCII art. I think that's the best way to describe it. I enjoy having nice terminal outputs. So I was really surprised, or not surprised, I was really happy to find that there was something akin to the Python FIGlet package in Julia. And it's just as easy to use. In fact, I'll go ahead and pull it up right now on my terminal. So here I have my terminal, and then I'm going to type using capital FIG, little l, little e, little t, using FIGlet. So now suppose I want to look at a nice Talk Julia slanted font. So the slanted font is my favorite font. If you go to the FIGlet.jl examples page, you'll see all these terms for different ways of formatting your output, your ASCII art output. And I like the slant the best. So what we can do is type FIGlet, so capital FIG, little l, little e, little t, dot render, and then you pass in the text that you want to render. So in this case, I'll do Talk Julia in quotes, and then I want the slant font. End out the parenthesis like that. So the first argument is the string that you want to output, and the second argument is the style you want it to output as. And then you close out that function, and then you'll see a nice little slanted ASCII art Talk Julia on the output.
Nice.
Real quick, let me look up like another one. So maybe some of the names are just like ridiculous. Like I just looked at my screen and it said like Big Money, Big Money, SW. Let's see what Bloody does. So I'm going to come back up to my terminal. I saw one that says Bloody. I guess that's kind of gothy, I guess. How would you describe that?
I don't know. Like a horror film title or something.
There's one called Def Leppard. I have no idea why it's called Def Leppard. Let's see what that looks like. So
maybe it's like the Def Leppard, the band's logo.
Let's see. Yeah, sort of, I think.
That's really hard to read.
Yeah, some of these are not. I've played around with a lot of them, looking for the appropriate font for my automated conjecture program, and I couldn't find. There's a lot that are not legible. Let's try one more. Let's try electronic. I can read that one.
Oh, that's cool. Yeah.
Yeah. Yeah, so it's a nice little touch to add on to terminal-based applications like the conjecturing program that I'm working on. So for example, just to show you like what the interface is looking like right now. I don't know, I just like it. It looks nice. Just to have that at the very top is
Yeah.
like your introduction before going to look at anything else.
Is that the slanted one that you're using?
Yeah,
there?
that's slant. That's my favorite one.
Yeah, I like that one too. That one looks good. Speaking of terminal output, I've got to mention this. Unfortunately, I don't think this is actually ready. I don't think there is a GitHub repository for this yet, but I just have to mention it because I'm super excited about this. So
Oh yeah, you were telling me about this. You are excited.
On Twitter, this person Federico Claudi has been working on a library called Term.jl, and it is like beautiful output for terminal programs in Julia. Recently, he tweeted that most features are ready in Term.jl and has some examples here. So for those of you listening to this and not watching on YouTube, we'll post a link to this tweet so you can see what these look like. But it looks really, really cool. So they've got things like text boxes where you can enclose text inside of a box. Everything can be colored. You can have different kinds of panels. So you can create like kind of grid type layouts and fairly complex ones, it looks like, as well. And there's things like panels, logs, errors, markup styling with text and colors in different modes. So you can have bold text, italic text, all sorts of stuff like that. So there's just some examples. Here's like some fancy logs that has nice stuff in it. Here's like a really fancy looking stack trace, which is actually quite nice. It shows you like the different lines are, separated. Everything is color coded, and you can see like it says, okay, the error is in which line, it was caused by which thing, and what is the actual error is in like a box at the bottom. It's all in red. So it really draws your attention to like what you should be looking at in the stack trace, which is nice because, vanilla stack traces in almost every language I've ever worked with are just, they're a lot to take in when you first see them. And it takes some time for your brain to just kind of parse what's going on and find exactly what it is that you're looking for. So I'm very, very excited about this. And just recently, Federico tweeted a poll about progress bar. So he's got some example of different progress bars that he's put together.
I love progress bars.
Yeah, and these are some really nice looking progress bars as well. So I'm really excited to see that coming to Julia. And all the work that Federico has been putting into that. So, Randy, what else do you have for us today?
Okay, so I know I've mentioned this guy before, but his channel's awesome and I love it. The Julia for Talented Amateurs YouTube channel has recently started working on has recently started producing new videos in a video series on machine learning.
Okay, cool.
And they're great. So I love the thumbnails typically. So I like Mr. Rogers behind the nearest neighbors.jl. Yeah, so he's I think still making them, right? So he's not done with this playlist yet. And so far he has 7 videos up. So walking through the basics of machine learning and covering some packages that I haven't played with myself. Like it seems that there's a support vector machine.jl type of package for support vector machines. There's decisiontree.jl. I've seen that. And with all of his videos, he's very thorough and it's entertaining. And I encourage our listeners to go and check out this playlist as he continues to update them over the coming weeks.
Awesome. Yeah, well, those look like great videos, and I know both. I know you're a big fan of him. I've watched a few of his videos, and it's really, it's entertaining. It's very entertaining. I love his sense of humor.
Yeah, same.
So the last thing I've got that I wanted to mention is a new blog that I found, and that is called Stats for Scared Ecologists. And I believe it's, which is a great name for a blog. The author is Guy Sutton. So I found this because Guy had mentioned us on Twitter that he had just discovered the Talk Julia podcast and will be listening to us now. So that's really cool. But I went and checked out his blog, Stats for Scared Ecologists. If you want to follow them on Twitter, it's at stats_ecology. But the blog has some really good stuff. There's a lot of R in it. So it's mainly focused on R and Julia. And from what I can tell, it's primarily R, but there is quite a bit of Julia content on there as well. And this article in particular kind of fits in with the other stuff we've been talking about, input and output. And this, it's called Import and Combine Multiple CSV Files Using R and Julia. And it's split into two sections. So there's a section on using R and a section on using Julia. Obviously, we're going to focus on the Julia section. But just to give you some context, it starts by saying, in this post, we're going to look at how to programmatically import multiple CSV files into a single data frame. And the post is motivated by a number of recent consultations that he's done, whereby the user has stored their data in an often large number of separate CSV files, with each file representing a different site or a month or a species or some kind of group, right? So you've got all these kind of multiple CSV files, and you want to bring them all into one data frame. So this talks about how to do that. And in the Julia section, it walks you through the code, and I think this is really nicely done. I really like this, the way that he describes everything here in the blog. So it talks about, first you need to import the CSV package and then this glob package, which was a new one to me, and I'm glad I found that because, we'll talk about what it does in a second, but import the glob package and then the data frames package. And then you use this glob package inside of the glob module. There is a glob function, and you can pass it this glob string. So you can use like these patterns. So for example, this one is star.csv. That's the first argument to this glob function as a string, and then the path that you want to search that pattern through. So this will glob the file, which is I think kind of the Unix Linux way of describing that. It'll glob the file path, and you'll get the all the CSV files that are inside of the directory that you pointed it to. Once you have those, then you can create an array of data frames, and it's all done in one line, which is really nice. It's leveraging the vectorization. So what you do is you use the data frame constructor, but you do data frame dot and then open the parentheses. So this is going to apply that data frame constructor to like some kind of iterable or like vector of things. And then inside of that function, you're calling it with this argument csv.file dot. So again, this is using that vectorization, and then open parentheses files. So the files is the vector that you got back from the glob function that has all the paths to the CSV files in it. And what you end up with this is a vector of data frames that have the data from all these different CSV files. In this case, all the CSV files have the same headers. So, you don't have to worry about anything like that. Obviously, if you have different different headers and maybe different types, you may need to do some additional processing for different things. But in this example, they all have the same headers. They're all the same. Each column has the same type in it. And in order to bring everything together, you use the reduce function and pass to that the vcat function as the first argument, and then the data array, which is the array of data frames with the data from all the different CSV files. So this is applying the vcat to the data array and then using the reduce function to concatenate basically all of those data frames together into one single data frame that has the data from all the different CSV files into it. So it's like 3 lines of code, which is pretty cool to get all this. And it's a nice article. It's well written and a very clear example. And it's also got how to do it in R. And one thing I just want to say is like compare the R code to the Julia code as I'm just scrolling through here. And you'll notice that Julia is a lot shorter.
Yeah. And I definitely like the concept here in that you literally this package, what was it called? Glob. So
Glob, yeah.
Yeah, you're just globbing. So that function is grabbing all the .csv files names, the strings as like their names in your current working directory. And then you apply the broadcasting dot argument with csv.file to each of those names, right? Which returns an array. And then you apply the data frames with broadcasting dots on that array, and each entry in that array becomes a data frame, and then you just vcat them, and it becomes one single data frame. It's like, it's very, to me, it's very simple.
It's like a little pipeline, where
Yeah.
each step makes a lot of sense. And
that was the first time I actually saw that like process, and I get it immediately. Like, I didn't
Right,
have to look at it for more than like 5 seconds to understand.
yeah,
Which
it's
is
really
rare
cool.
for me. On this note of like just having like resources to understand things, I wanted to add something that I wasn't planning on talking about this episode, but
Sure.
I have noticed on like my YouTube channel, on the Talk Julia YouTube channel, and on Twitter that every once in a while, like consistently, we are asked to like provide like resources for certain things. In particular, I've had quite a few people um, ask me for like books or references for someone that already kind of knows how to program, but like just needs like a Julia reference. And as we've been going through today's episode, I was reminded of this handbook that I have and I keep on my desk. It's called the Julia Language Handbook by George Root, and it's old. It's from 2019, but it is with Julia version 1.02. So it's still version 1.0 and higher, which is like basically a lot of things are very similar to what is done now with Julia version. I think of 1.7 or something. I don't know.
1.7.
But yeah, so like a lot of the things, like a lot of these simple things, like for example, the reading and writing, like file input output, like IO stuff. Like there's an entire chapter on that in this book. I have it in front of me right here. And I was looking at it and I was like, all of the things that like we like searched on Google that weren't there immediately or kind of hidden,
Mm-hmm.
like all of those things are in this little handbook. It's just,
Cool.
and it is a handbook. It's not like an actual textbook. It doesn't explain anything in detail. It's just like a reference guide for basic tasks that you might want to do, including like the next chapter after this input output is like joining data frames, I'm pretty sure. Right.
Cool.
So like, it's relevant. And for those of you that prefer like having like books to hold on to when you're like walking around, going to coffee shops or whatever, you know, I recommend this book. It's like a nice little reference guide to have like on your desk or in your backpack if you're learning Julia from another programming language.
Nice. Yeah, that's a good thing. I have not seen that book, so
yeah, it's the one I always like keep for like, or I used to keep for like quick just references.
Because I would imagine that not a lot of sort of the basic syntax has changed since
No,
version.
it's for all intensive purposes for this like the basic things, like the packages have definitely changed, but
Sure. Yeah.
the core Julia is more or less, it seems to be the same. And if it's not, you'll get like a deprecation warning or something.
Right. Yeah.
And it's easy to like, oh, like you're still like getting close to where you need to be.
Yeah, for sure. Awesome. Well, I think that wraps it up for us. So, Randy, thanks for hanging out and talking Julia with me.
Yeah, thanks, and I'll see y'all next week.
All right, take care. Bye.